In this video, we look at the procedural steps in transportation model. So we'll just briefly touch upon all the steps in solving a transportation problem, and each of these steps is explained in detail in the other videos. So step number one is formulation of a transportation table. So typically in a transportation problem, you'll have some sources of supply like factories or plants. And you'll also have some sources of demand or the destination. And the material needs to move from these sources of supply to the destination which has a demand. Now each of the supply source will have a supply capacity, and each of the demand destination will have a certain demand, and there will be a cost associated with shipping the material from each of these sources of supply to each of these demand destinations. So in this step, basically the supply from origins, the requirements or demand at destinations, and the cost of shipping from these origins to the destination is expressed in the form of a matrix which is known as the transportation table. Now, step number two is to establish a basic initial feasible solution. So after we have formulated the transportation table, the next step is to find out a basic initial feasible solution. So this solution is expected to satisfy all the demand and supply constraints. However, this initial feasible solution may or may not be the optimal solution, or in other words, may or may not be the best solution. Now, there are multiple methods of establishing the basic initial feasible solution, the most common of which are northwest corner rule, second, least cost method, and third is Vogel's approximation method. Now step 3 is to examine the initial feasible solution for acceptability. So after we have established the basic initial feasible solution, we want to find out if this solution is optimal or not. However, before we proceed with the optimality test, we have to perform step number 3, where we find out if the initial feasible solution is acceptable to proceed with the optimality test or not. There are two basic conditions for step number 3. The first one is that the number of allocations should be equal to m plus n minus 1, where m is the number of rows and n is the number of columns. And second is that the allocations should be in independent positions. What this means is that it should not be possible to change any individual allocation without either rearranging the positions of the allocation or violating the capacity and demand constraints. Now, after the solution has passed the acceptability test in step number 3, then we have to move to step number 4, which is to test the solution for optimality. So in this step, we test if the solution available is optimal or not. We can say that a solution is optimal only if there is no other alternative solution available which will provide lower transportation cost. So there are two methods which can be used for the optimality test. The first is stepping stone method. And the second one is the modified distribution method. Now, after the optimality test, if the optimality test shows that the solution is not optimal, then we make changes to improve the solution, which is our step number 5. So step number 5 is to make changes to improve solution. And after that, we repeat steps 3, 4, and 5 till the optimal solution is obtained. So these are the steps in solving the transportation model, and each of these steps is discussed in detail in the other videos.